Hello, right, there's a few things going on here. First thing you need to notice is this piece here. Well, this is out the front of the Holbrook lathe. It sits down in this area here. So you probably guessed, I've experienced a problem. Now, I experienced that problem while I was making this part of the flange for the wind turbine mount. So the wind turbine, the bearings for the yaw are going to be on there. And I'm going to be making a wider 4-inch flange which is going to screw onto that and then bolt into holding position. So I've just turned down all of that. Okay, that is it for the night. There's smoke everywhere. I've took 20mm off that in about an hour. That's 316 stainless. And then I'd started doing threading. I've cut a 1 3/8 by 12 thread, which is 1 3/8 UNF. And when I was cutting that, I was doing it in reverse, cutting a right hand thread away from the action just to make it nice and safe, in back gear because my belts slip on this, so I can't do it in direct drive on stainless because I get too much belt slippage and it becomes quite annoying. The lathe stalls, the motor's not stalling, the belts are slipping to the point of stalling, so I put it in back gear and I do back gear and it's perfectly fine. I just run it at higher speeds. But the lathe started making a growling noise intermittently. Obviously, it did it 3 or 4 times in the whole time that I was cutting those threads. Now, clearly, after I'd finished these, and these are 2-dimension with threading wires, I've took the gearbox, the headstock gear cover off, and had a look inside. Couldn't see anything. I couldn't see any teeth missing or anything, so I investigated further, and it ends up that the lathe shaft, which the back gear selector runs on, it's like a dual gear. It looks a bit like the gear which is from my mini lathe, but obviously longer. It's about this length and about the same size as this inside there. And it slides forward and backwards on the lower shaft in there. Might not be that size, but it's not far off 3 inches in diameter. And then the small gear is like on that end there. So if you can imagine, 1 gear here and 1 gear up here, and then a little end in between, about 3 inches long in total. Well, it looks like the smaller gear, which engages with the big gear attached to the spindle nose here. Let's take it out of back gear because I don't want it in back gear. So there's a big gear at the front here which is attached to the spindle nose, and it's got a smaller gear further back, and when you slide the sliding gear forwards it engages the small gear to a big gear, and then the small gear on the lathe shaft to the big gear on the spindle nose, which reduces the spindle speed considerably and gives you a lot more torque. Well, the bearing at the front here, it's a high precision bearing which the shaft runs on. There's about 1 millimetre of lift in it. It's shot. So the gears are moving down a millimetre, and then clearly the pressure of turning at some points it was starting to skip gears. Now I believe that the gears are worn, and obviously the slipping didn't do any good to them neither, and they're hardened gears in this. Probably case hardened, but I can't make case hardened, So I've got to take the gear out, inspect it. I'm suspecting the gear is going to be mashed up pretty badly. I'm expecting it's going to have lost, you know, probably a millimetre off the crown of the gear, whatever you call it. I don't know how the gear works. Got a gear here. I reckon the top of the gear is going to be worn down a bit, because there's, even on that small gear, there's more than a millimetre of engagement. Although with a worn bearing it might be okay. I don't know until I get it out. But that's where we're at. So I'm latheless unless something happens. Now I haven't finished making all the parts to get the mini lathe 3-phase yet. But the DC controller is broken. And I bought this DC controller when I was rebuilding the mini lathe, thinking that I was going to put the 200 volt motor on, which I had, and run it with this. But I decided I'll just go for a 3-phase, and this was only about £12. It's a little DC controller. I can't remember the exact specs on it. I think it's 0 to 200 volts, and it should take that motor, which is almost the same as what's in the mini mill. I think it's a 500 watt that can take, and this is a 300 watt. I'm not entirely certain because there's a lot of different specs on these motors. Anyway, I've got a bit of footage from a mobile phone. Long story short, this motor runs with the speed controller from around about 40 RPM all the way up to the maximum speed at 200 volts. Right, the motor might rock. Working. I've got the first gear going in there, obviously not together yet, and the second gear on its shaft, because that did not fit, so I've had to stone the shaft because it wasn't round anymore, because somebody forced that keyway into it and I can't get it out. So there's no way of polishing it normally, but that shaft was not round anymore in the centre. It had massive, you can see where the galling was. It's got a bit of galling in that gear now, but it's all good now. Which is not its maximum speed because it's a 300 volt motor, but it's a good speed. So without any modifications, apart from fitting that speed controller in the front cover, which I've just marked up in there, you see a little bit of a Sharpie mark in there. I'm going to drill a hole in there and mount that in there somehow. With that small modification, I can then refit this motor, and I'll have a variable speed motor on the mini lathe, which is what it needs. And I'm in the process of fitting the metal gears into the headstock right now. Now, this is the lathe shaft for the mini lathe, and it had the plastic gear running on it, which I've chucked in the bin now, so I don't need it anymore. And that did slide up and down this shaft, but these plastic gears are 25,000 sometimes oversized, whereas this gear is engineered and it was 0.04 of a millimetre over 12 mil. Good clearance for a sliding fit on an exactly 12 mil shaft. If you're looking closely now, this shaft isn't quite as shiny as what it was. It was that shiny, not a bad ground finish, and now it's got that scuff all over it. The reason being is, this is what I think happened. In the factory, they milled the slot for the keyway, and it wasn't quite big enough. So, instead of dressing the key slightly, or dressing the keyway, or making the keyway proper, they decided, I think looking at it, they put it into a V block on a press and then press that keyway in, because that is not coming out. I have tried to get that keyway out to the point of going towards damaging it, and it wouldn't come out. And then I blued up the shaft, and bit by bit, by flat wheeling this a little bit and massaging around here with a stone, I slowly got this to go on the shaft, bit by bit. And now I've got it to a point where it gets stuck there a little bit going that way, but that's not the way it goes on this way. So as you can see, it's not perfect, but we've got a sliding fit now. And as I was doing it, I was blowing it up and using oil and looking for oil smear lines and what have you. And what it looked like it had happened is a V-block, because it had a couple of bulges. It had three distinctive bulges basically, and it just looked like it had been rested in a V-block, and then that was pressed in. So it splayed the top of the shaft out a little bit as it's done that. So we had a bulge here and a bulge here, and then there was a bulge in the bottom as well down here. So yeah, I was just going at it with a stone and a diamond lap, and bit by bit I got it so it goes on all the way. So now the gear change can work and the lathe shaft, and now I can put the drive gear goes on the end here to drive the lathe shaft, and obviously the lathe shaft transmits its power either in high gear or low gear up to the headstock. The headstock gear fitted perfectly first time, thankfully. There was no messing about with the spindle, it's all with the lathe shaft, which is not as critical. These bearings, they'll suffice because I'm rebuilding the lathe anyway, and it will have new bearings in it, but I need it working. So I'm at that point now, because I think I'm going to have to make the gear. Now the mini lathe should be able to rough out a piece of EN19 to a similar shape to that, but obviously bigger, and then I'm going to need to cut teeth into it. So I'm just looking at a dividing head right now, and I need to measure the gears inside here for pressure angle and whatever you call the gears, modulus and something else, I can't remember now. Diametral pitch, that's it. I think they're 10 dp these gears, but the pressure angle is not the same as a Myford, so we might be looking at a 14.5 pressure angle. And I've got to make those gear. I've got to make that gear, I think. But I want to strip it down first. I don't want to strip this down yet fully. Now I found out what's wrong with it, because in direct drive it will not affect that lathe shaft. That lathe shaft will not turn in direct drive. So I'm still okay doing small diameters on this in softer steels, because I can do that with minimal belt slip at the moment. So I'm going to put that plug back in to seal it up so oil doesn't leak out constantly. Take the headstock to bits a little bit just to see how much oil's still in there, top it up if it needs doing, and then once I've got the mini lathe, if there's any parts I need to make with this lathe for the mini lathe now to get it running, I can still make them with this lathe, and then I get the mini lathe running. Now the other option was, I'm going to be getting a bigger lathe. It's going to be hopefully a Triumph 2000, 2500, 50-inch gap bed lathe. That's what I desire. At present, there's a machinery tool dealer in Castleford, which is North UK, about 80 miles away from me. They have an Harrison 13-inch, or I think they call it a 165, Harrison 165 lathe. It's not a gap bed, it's only 13-inch swing, but it has got everything: faceplate, 4-jaw, 3-jaw, catch plate, centres, drill chucks. It hasn't got a quick change tool post. It's got a taper turning attachment as well. It's got everything really, and it was probably a training lathe because it's 240 volt. It's only single phase. But I haven't got the room right now because my garage isn't finished. In an emergency, I will get the lathe that I require and chuck the car out on the front driveway and cover it up. But I want to try and get the mini lathe working for any work that's required to get this lathe back up and running reliably, and then I'll strip the mini lathe back down again once the Holbrook C8 is working again. That's the plan. Okay, this is the mini lathe modifications so far. At present, what we have is I've made a little washer for the back end of the, or should I say a big washer for the bottom end of the lower drive gear, and that looks a little bit like a bucket, and obviously a recess for the Allen key to sit in so it's nice and flush. And the idea of this washer is because the shaft sticks out a little bit here, so yeah, you can see the shaft there now. I'm quite happy at that. I mean, it wasn't exactly difficult to make a little washer like that. It goes on there beautifully. Alright, so that's modification number 1. Modification number 2, that's behind the metal gear. I'm using it as a spacer. I've made a little brass spacer. It's a certain millimeterage. I measured it. It's a long time. It's at least three days since I've done it. Anyway, what that does is it obviously spaces it out a little bit, and it brings the outer gear into mesh if you put it on the right way, like that. And clearly the cup washer, whatever you want to call it, the retainer, whatever you want to call it, that holds the gear. Well, it was supposed to hold the gear. Let me just tighten it back in again. Right, get it in there. Problem is, I made it a little bit too short. That's fine. Another washer's going to go in there for the time being, and I'll remake the cup washer at another point in time. Now, this gear space in here wasn't very good. As you can see now, they're lined up very well. They're a bit wonky. They don't run true. And it goes from being perfect to being around about, well, less than a quarter of a mil off of it. So the engagement on that is a lot better, and the gears are straight. And the way I did that was with the bottom pinch bolt. If you can see that. So this lower pinch bolt, it has a double-ended slug arrangement, and I just faced it off a little bit so it could go in further, and that allowed the banjo to go in a little bit, so that lined it up to this. Now this is the complicated one. A little bit different down for that. So there's some modifications went on this one. And that's all for gear alignment as well. Still got 2 more to do, but it's acceptable the way it is at the moment. I'll just take this one off and show you what I've done on this one. Excuse me. Excellent. I've got coronavirus. Excuse me. So inside this one there's a little, again, cup washer or a spacer, and that, obviously you can see it's brass, that fits inside the lever like that and presses against the aluminium, and then the gear here presses that against the aluminium and reduces the play in the lever so the lever doesn't flop around. Just zoom back out a little bit. So the release lever here, it's got quite a lot of slop in it. It still has. So we can remove that like this. That comes off. And I've stoned the back of that off to get it even flatter than what it was. You can see the brass bush in there now. And you can see the little lug it sits on. Okay. Now I've scraped this flat and I'm getting good coverage all the way around. I can actually see it now where it's rubbing. It's got a good wide plane, goes all the way from there all the way into the centre, and it does the whole plane around here, but there's no coverage around the outside, around this area here, which still allows it to rock side to side. I can reinstall it. It's a bit harder to reinstall than it is to take off, but there we go, we've got it. Yeah. Now there's some other modifications inside here. I'll show you those. Maybe. So if you put a circlip on the right way, they come off dead easy. Extremely annoying to get off. Yeah, there we go. So behind that washer there's a keyway, yeah. So behind that keyway there's a washer, and there it is there. If you can just see it going up there, yeah. It's made that, and that is 35/100th of a millimetre in thickness. When you get the gear back on properly, and then having the circlip on correctly, you can flex your pliers. Look, if you pull it the right way, it does that, and it doesn't flick off when you come to what's good. So always put your circlips on the right way, and then when your circlips on, it doesn't go in the land because it's such a tight fit now. Put your circlip pliers back in again, push down on them and twist. And you see it go in? All I did was twist. You just twist. Just twist the circlip. Ready to tap it, just twist it side to side and then it goes in. And what that's done is give me that amount of free playment, that free play there. But more importantly, although there is still a bit of free play there, it just takes a bit of space out of the gear, pushes the gear this way a little bit, which makes the engagement onto these two better, I think. I can't remember, I'll have a look, put it back on again. It does something. It's a couple of days since I've done it now. And fitting this isn't as easy as it could be. There we go. Right, now, so it's pushed it away, that was it. It's pushed it away from those other gears a little bit, but it's made the engineering of the bottom bits less. I'm going to take less off to push these in because it's pushed that gear out a little bit. But it does mean that now I've got to make the two new studs here for these top two gears to bring those gears out a little bit. This should be fine. We've got about 80% engagement. It's a small gear to a bigger gear, so got plenty of torque advantage there, at least 2.5 times its torque advantage there. Now on top of this, on top of all that, we've still got a problem here. So you can see that, yeah? Get my finger out of the way, you've still got a bit of play. So there it's alright, we can go that way a bit. Okay? So that's fine, and it doesn't flex. It would flex the other way because I've scraped the aluminium plate and stoned the back off. It doesn't flex both ways, it only flex that way, and that's because that washer's in behind and it's pinching it. But we've still got a little bit of play. Now, that's the neutral position. You can see the spindle up here turning, and put my finger on it, you can see the spindle is turning, and the gears underneath it are not rotating. So neutral now works, and it doesn't engage, it doesn't skip on these gears a little bit, which the scraping up here did. That's the scraping of the aluminium plate, that sorted that out. And when you put it into gear, as you can see now, it's turning the gears. Put a finger on the gear, and it's going round, round and round and round and round and round with the gears. And then reverse, or actually this is forwards, and now it's going the opposite way. So basically I am 95% there now, and I don't need to do these two desperately. Be nice, but they're not desperate. I mean, lathe, I didn't want to get this far, and now the mini lathe, I didn't want to take it this far right now. I wanted to strip it down more, but the problem with the hole block has forced me to get this working. Now, I'm not happy about this lever, still having that little bit of play in it. And the plan I've got for that is this little stud here where the bolt goes in. So this is the retaining bolt for that. Okay, I've got a new nice thick washer for it. When I tighten this up now, that stud is below surface, and it just becomes too tight, and it's also forcing everything that way because there's nothing for it to rest on, so it's no good at all. So I can't put this retaining bolt in at present, which is annoying. It'll be alright without it. Everything else I've done to it, it is perfectly okay, so there should be no rattling loosage. But to rectify that situation, what I'm going to do is I'm going to put this in the forge or on the hole block, and I'm going to clock that hole there in, centralise it, and use my scrape surface here underneath this gear, which is now perfectly flat, and I'm going to use that to clock it in axially, is it? I don't know, whatever. And once I'm centred on that and I'm square to the plate, then I'm going to turn the outside of that perfectly round, and then I'll make and I'll turn the face around here as well. I'll get this face down to a certain diameter, and I'll make a spigot reinforcement bush which I'll lock tight onto that, which will come out here somewhere, and then I'll trim it to the right size and the right shape and get some JB welding behind it or something, or might silver solder it, I don't know yet, to stop this rocking, this lever happening. And that'll obviously come out to the right height for that washer to sit against, so when it pinches it just leaves the slightest little bit of play, and it will all be tickety-boo, and that will be absolutely perfect. Well, it will be good enough, because, well, everything on this gear train was not good enough. That's going to be excellent. And the other reason I'm making this big bush is for a later instalment of an electronic power feed, electronic lead screw. So the rear cover, which is here, the rear cover, once I've done all this, I'm going to be drilling a hole in it here and mounting a stepper motor on here, and that will have a hex drive or a spline drive, and I'm going to cut hexes or splines into this washer. So when I clip this on and screw it on, I'll get the wires out of the way, it will go on. Once that's bolted on, I'll make it more secure like that. There'll be some extended studs in it so it'll hold it really secure. Then I'll have an electronic lead screw, and for power feeds mainly. I don't think I'm going to go as far to make it into threading because I just don't see the point, but making ultra fine feeds on this is brilliant. The finest feed this will do is 0.5 millimeters per revolution. That's what I've got it set at now. Set on the cover here. All my feeds there. That might happen soon because I'm pretty certain that I'm going to need the ultra fine feeds for this lathe, because I don't think it can take any kind of heavy cuts until I've modified the saddle area to make it really rigid. And that's where I stand. I really didn't want to go this far with the mini lathe. I really wanted to strip it down further with the headstock and upgrade the bearings and upgrade the spindle. I want to put the Camlock D12 on like that's on my whole box, so I can put all my whole box lathe chucks onto this and vice versa in between the two, and use its collets in here, which I've spent time making now. So yeah, we're not there yet, but this is now working with the original motor that came with it. It's just got the speed controller in that I've had for a few years, just sitting around doing nothing. Works a beauty. Alrighty, I've spent some time. As you can see, it is nearly back together. Yeah, these wires for the speed readout, I'm not sure if that's how they go, but I think this wiring wasn't great. I'm in the way, I'm in the way massively. Right, anyway, I've got a temporary socket wider because there's no power socket down on this wall, so I'm just going to plug her in and switch her on. Ooh, we have a light. We have a light. Right, I suppose this will be forwards, maybe, if we're lucky. And nope, that's backwards. So that'll be forwards. That'll be low speed, I should imagine. And that's high speed. Let me clamp something in it. Otherwise the jaws will be flailing everywhere. Not good for them. I want to make a cut now. I've got a crappy tool post, I can't. Okay, she's running. Let's simply engage some gears. Let's see if this is forwards. Oh no, we're definitely resting on the wires there. Is that in gear? Yep, that's in gear. Lead screw. Oh, the carriage is moving. All by itself. That's reverse. Yep. Backwards, threading down, threading down. Threading oil, does that work? Just drawing the threading dial out to get the right Allen key. See if that spinneth. I think that's it, just rest it on. Threading soil, working, very good, very good. Into threads, left hand threading, disengage, turn off, put back into forwards. This gear is not very positive in its action. There we go, that's better. Got it. Yeah, got it. Yeah, that's working properly. Back into high gear, it's gone straight in this time, sweet. Try to put it to neutral. Neutral is very difficult to select on this thing. That's neutral there. That's better. So I've got a safety switch wired in, got a on warning light, got a forward and reverse, a safety fuse and a switch which falls off, so I might just turn this for a start. It's a one-way tool post. I'll show you in a minute. Let's get this cut on. This the Allen key? Yes it is. I want to show you what I mean. I'll just get this first bit out of the way on my first play. Two will do for the time being, it's just a piece of plastic after all. Some goggles so I don't get flicked in the eye. Some goggles. Let's go. First chips. First chips. Here we go, with extra speed. First chips. There it is, first chips. Oh yeah, I'll just push it on this. plastic, no problem. Which is what it should be anyway. Okay, that should suffice. Let's see, maybe I've gone too far, who knows. Does it go on? Yes, it goes on now. Jobs we've got to do. First chip's plastic. Let's see what kind of chip we got. Who cares? I got chips from it. It was nowhere near cent. It was about half centimetre under. Oh, I was going to show you the tool post. Let's show you the tool post. And why this tool post cannot be explained as rubbish, because it is beyond rubbishness. I don't know if you can see that. You're just going to get rocking tools on that, aren't you? You see the, well, it's milled and it's left 10,000 lands on it. I don't know if we'll be able to get in there and see it. Maybe like that. There you go. How's that? Look at it. You see it? Deary me, that's bad. Very bad. And the spring missing with the detent for this. Very nice. Looks like I'm making a tool post for a start then, don't I? Because I was planning to do it anyway. I need to clean up the chips. Just remember not to use it until it's workable now. That is wicked. Lathe working. Doesn't seem to be very powerful, but the thing works and it takes out. It's a bit noisy, but there you go, it's got metal gears there. Probably some bedding in.